the process of integrating those requirements into the existing environments are sometimes such a barrier to entry that it would never even make sense to get started.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions, and he is going to be introducing the subject and the guest of today's show. Andrew, how's it going?
I'm very well, thank you, Nate. Our guest today is Sam Elsner. He is a senior manager for the Kepware-focused application engineering team at PTC. Now, for anyone not familiar with the industry, Kepware is a long-standing industrial automation provider, and PTC acquired the business in 2016. And we're going to be talking about Cryptosystems. We're going to be talking about connectivity. We're going to be talking about, what it's like in the trenches, working in an environment where there's more and more connectivity every day.
Okay, then without further ado, here's you and Sam.
Hello, Sam. Thank you for joining us. Before we start, can you tell us a little bit about yourself and about what you do at PTC?
Absolutely. Thanks a lot for asking me to join, Andrew. It's a pleasure to be on the podcast. It's an honor to be able to talk with you today. I manage our sales engineers, so our applications engineering team who focus on Kepware products. And what Kepware spends our time doing is writing communications tools and products for industrial automation systems. So that's used in wildly different ways than it was, say, even just 10 years ago, but still within the realm of configuring network, serial Ethernet communications for use cases around industrial automation and operations technology.
At PTC, I know that the Kepware product line has a lot to do with connectivity, and connectivity is a big piece of industrial security. Every connection that allows data to flow is a potential attack vector. So before we get into the security end of it, let's talk about connecting devices. You're connecting devices to control systems. You're connecting control systems to enterprise systems. You're connecting out to the cloud. What's going on with connectivity in the modern world of industrial automation?
I think it's worth looking at what's happened in the past in terms of digitization as we look at what's happening right now. And we can use Kepware as a case study for this. So Kepware started in 1995. We started in 95, 96, and we developed a number of drivers that were quickly utilized for various, typically control software applications managing hardware. And over time, that's been still a very significant portion of our business. A lot of that was, hey, I have one defined northbound interface like OPC-DA or Microsoft Dynamic Data Exchange, and I need to go talk to an Allen Bradley. Kepware, can you make that happen for me? And the answer would be sure. So what we spent a lot of our time in, and what we saw a lot originally, and still quite a bit today, are desired for a field bus control layer protocol support. So, HMI panel drivers, SCADA drivers. So our initial work in HMI panels evolved into more centralized SCADA system drivers. That took us into OEM relationships. And really, it was still, though, all about, hey, we have a very finite, small amount of northbound protocols that we need supported. And these are typically DDE and OPC-DA. And we have a wide variety of southbound hardware. Typically hardware to talk to. So it's great you guys have Rockwell, controller support. What about Siemens? What about Omron? So what had happened in the industry that we had been in for maybe 10, 20 years was a whole lot of development in what I'd call, say, the southbound layer, the control system layer, support more hardware, support more PLCs. And for us, it was really about building support in with whatever method the vendor would allow access. So sometimes we had a robust, feature-rich protocol with whole lots of options, and it might take a year for us to implement something like that. We turn around and have another request for a far simpler protocol, and we would build a driver for that and add it to our ecosystem. So over time, what's happened, you can almost think of it like this. Other folks in the northbound are really interested in that southbound data. So not only are we still seeing a huge variety of new hardware vendors come onto the scene for programmable automation controllers and programmable logic controllers and machines and other software systems involved in the control network and process control layer, but we're seeing a whole lot of desire to get all of that information to other places where it hasn't been received before. So, we see this really as an increasing interest in OT data, operational tech data, process values by other parts of the business and by other commercial entities. And so we've been allowed to increase the, say, brand recognition of Kepware and the prominence of Kepware, and almost created sort of a technology paradigm of using this middleware layer. And so a lot of the times what our customers are looking for now when they come to Kepware is they've got Kepware in the environment speaking a number of southbound control layer protocols. Now they're interested in how to get that data over the internet to their favorite cloud provider, whether it's a cloud in APAC or if it's one of the clouds here commonly used in the US like Azure or Amazon Web Services or Google. We're also seeing a lot of adoption of big data systems like Cassandra DB and InfluxDB, big storage buckets. So for us, it's still all about connecting things together. It's just that the stuff we're connecting together, they're different systems, they're new systems, they're old systems, or they just haven't had connectivity before, and they're in languages that we typically haven't seen in operations tech. And of course, there's a big follow-on there to how do we do this securely.
So Sam used a lot of terminology there. Let me try and introduce bits of it. A lot of the interview here, he's going to be using terms like level 0, level 1. This is the Purdue model. It's the same model that's used in the IEC 62443 standards for industrial security. Level 0 is physical equipment like turbines or pumps. Level 1 is the computers that are directly connected to the physical equipment. Level 2 is the control system, the operator interface, maybe the historian. Level 3 is plant-wide systems, when you have lots of control systems in a large plant. Level 4 is the business system. It's the enterprise network, the IT network. And level 5 is the internet. And usually when you visualize these things, imagine a picture with level 0 network, a bubble on the bottom and the internet on the top and everything else in between. And most of Sam's conversation here is sort of from the perspective of the layer 2 system, where the operator sits, where the operator has the human machine interface, the HMI user interface to the control system. If you look down to the level 1 and level 0 stuff in the diagram, in his terminology, that's southbound. It's communicating with devices. If you look up in that diagram from level 2, it's the plant network, it's the business network, it's the internet. So it's talking to the business systems. And, Sam uses the word Kepware a lot, and he's going to use it through the whole interview here. Yes, by Kepware, he means the stuff that, Kepware sold, that PTC acquired, that product line. But he also means sort of more generically a product, not a product, a protocol translation function. So Kepware, back in the beginning, they made their claim to fame. Yes, they wrote a whole bunch of device drivers. They were all about communications protocols. But they also got into OPC, and OPC was sort of the first very popular piece of software that had lots of device communication protocols on one side of it and a very small number of what he calls northbound communication protocols on the other side. And the market opportunity there was you don't have to write hundreds of drivers for all of this equipment for your new HMI product or your new historian product. All you have to do is write an OPC driver, because the OPC products give you access to all of those other devices. They translate the OPC protocol into these other protocols. So when he uses the word Kepware, what he means is a piece of middleware that translates the device protocols from layers 0 and 1 on the bottom of the diagram into the business-friendly protocols on the top of the diagram. So that all sounds good at the high level. I mean, everything is getting more connected. But, when we talk about the technology, Can you give me some examples here? What are people using to get connected? How does it work?
Yeah, the great question. So getting into the nuts and bolts of how we do things, Kepware has a number of protocols at its disposal to move data to different places, different systems. And so when we approach these things, typically we ask our customers, okay, if you're interested in getting the data to a cloud platform, which cloud is it? And then we're familiar enough with these cloud vendor designs to say, okay, we know how the cloud vendor would want you to get data into their platform, Mr. Customer, Mrs. Customer. Does this method work for you? So let's take Microsoft Azure as an example. A customer comes to us and says, hey, I have Kepware at the process control layer, or maybe I don't, but I have some PLCs or some PACs or some systems that I need to start collecting data from. And I'm not sure what I'm going to do with the data yet, but I know I want to put it in Azure. It's a very common scenario. And so we would say, okay, let's do investigation for the southbound or control layer connection. Oh, hey, look at that. You're running an Allen Bradley L82 Logix device. Great. We have a driver that can expose variables from that. Do you know what variables you want to expose, Mr. Customer? Great. Okay. So we'll look at that. I'll look at that again from a security perspective in a second. But then we'll take Kepware and say, okay, Mr. Customer, Mrs. Customer, you wanted to move this data to Azure. Okay, here are the 3 or 4 languages. Here are the 4 protocols that Azure can support for message ingest. Here's what they'd recommend. Maybe you get the recommendations directly from a Microsoft tech person as well. And what that eventually might look like is, say, Kepware connected to a process control network. Kepware lives in a DMZ, let's say in this design. There's an inbound port opened in the firewall protecting the PCN from the DMZ, the process control layer from the DMZ, and opened for the specific data transport type, maybe TCP, and the specific TCP port that we'd be using for that, maybe 44818. From the Kepware side northbound, this gets really interesting, especially with these modern cloud vendors, because they're just producing a whole lot of new technology. What we lead in with, all other things being equal, is a Linux-based Azure IoT Edge runtime module. So it would run in what's called a container. This is for folks familiar with IT containerization systems. This might be Docker. It might be a variant of Docker used by Microsoft called Moby, M-O-B-Y. So you'd have a Moby runtime on the Linux PC. You'd have the Azure IoT Edge runtime ecosystem deployed on Moby. And that tool, it has an OPC UA client module within it. So it'll make a direct OPC UA connection to Kepware. And then peeling back the layers of the onion about how that protocol works, it's a solicited protocol. It's a client-server protocol. So the client is in the driver's seat. The client's in charge. So that little OPC module inside of the Azure Edge runtime is going to know which Kepware to go get data from, going to know which tags it wants, and it'll initiate a connection to us, request those items, and then by virtue of the behavior set afforded to us in the OPC UA protocol, we can securely deliver values as they change or on different scenarios to that Azure IoT Edge runtime component. Now, from the runtime component, again, this is implied that the Edge component is actually living inside of your network. Maybe it's living in the same DMZ as Kepware. Maybe it's not. Maybe it's in a different portion of the network with a IP layer and TCP route possible. But either way, this would be actual Edge Azure technology deployed at the edge. So it's like you're taking a little piece of Azure and bringing it local to you. And then from there, the outbound connection from Azure Edge technology to Azure Hub works on a protocol. Typically, it's a protocol called AMQP. I think its acronym or initialism stands for Advanced Message Queuing Protocol. And it's an industry standard. Microsoft has adopted it for inter-process communications within Azure and then external communications within Azure. But they also support MQTT, and to some degree, they also support HTTP. So what we're seeing is a lot of these vendors supporting multiple ways of getting data into those platforms, maybe selecting one for use with some of the technology they're deploying at the edge. So that whole stack, again, looks like a unencrypted, solicited protocol from PLC to Kepware through a firewall. Typically, Kepware might be in a DMZ. and then maybe an OPC UA connection to an Azure IoT Edge Runtime, OPC Publisher module, and then an AMQP connection from that module up to Azure IoT Hub in the cloud.
So lots more terminology. Let me try and simplify this a bit. Docker is a vendor. They produce containers. A container is just a way of packaging up complex applications so that they're simpler to manage. So when you hear the word container, just think of big complicated thing made simple, dropped into a box. Azure is the Microsoft cloud. AMQP, MQTT, these are protocols that Azure likes. They're called publish, subscribe. A lot of cloud applications nowadays like these protocols. So these are the three things. We got the cloud, we got a container for putting complicated things together, and we got the cloud application. Put it all together. How did this stuff work? Well, in the old days, in the early 2000s, when I was still writing code in the control system space, we had very simple problems. We had, hundreds of these device protocols that we all hated, because who wants to write 100 communication protocols? Nobody. You had devices talking their protocols, so we would, buy or build an OPC server. And now you've got that thing, that OPC server talking to the hundreds of devices, and you've got one protocol coming out the top. And you can connect that one protocol into your HMI and into your historian, and you're done. And, I'm grateful to Sam because he sort of brought me up to date. I haven't touched this stuff in over a decade. In the modern world, it's still very similar. You still have the devices. You still have their horrible 100 protocols. You still have a piece of middleware, an OPC server, like, he calls it a Kepware, but it's a little box that translates from these hundreds of things you don't want to touch into one or two protocols. Which protocols? It translates them, the OPC translates them into OPC, and there's a box, the container, that has a piece of the cloud in it. It has a piece of it has a whole bunch of Microsoft technology. So we're talking devices to OPC to the cloud box out to the cloud. That's what's different. In the old days, it was devices to OPC to the HMI. Nowadays, it's devices to the OPC, to the box, and out. And, a lot of his talking about where does the box go, there's firewalls here, there's ports open there. You can put firewalls where you like. Some people will put the OPC box in level 2 of the Purdue model. They will put the cloud box, in layer 3 or layer 4. And then, of course, the cloud is out in layer 5. Or, they might jam it all down in layer 2. There's different ways to package this stuff up. But basically, we're still in the job of translating device protocols through a couple of different layers into the cloud so we can get access to the data in the cloud. Let's come to industrial security. PTC is a vendor in this space where industrial security has sort of been going on for 2 decades now. A big part of that security thing is encryption. Now, you've mentioned that you do a lot of work with Cryptosystems. What's the state of the world there? What are people asking you to do here?
It's a great question, Andrew. So just like you said, security has been a central theme of operations tech systems forever, far longer than I've been in operations technology. I think what we're seeing today is that more and more attack vectors are available now. And then at the same time, there's increasing attention to operations tech and industrial control system infrastructure from nefarious players, individuals, groups, state actors, Russia and China as an example. So customers are asking us how to connect HMI SCADA or directly to devices. They're continuing to ask us those things, but they're also asking us, how to expose this data to other systems securely, and then they're also asking how PTC does it. So when I answer this question, I'm pulling in large part from what the target systems support. So these are I'm not going to be able to make a backnet protocol any more secure for you than it already is just by adding Kepware in between. If you're just looking at a network connection between Kepware and the device, like Kepware not going to suddenly come in and say, hey, BACnet, don't speak with me using a plain text unencrypted standard. I want you to now speak to me using an encrypted standard. We can't do that unless the device actually supports something like that, and unless the BACnet specification has been updated to support some level of encryption. As an aside, I do believe it has. I don't believe that Kepware has adopted that encrypted version of BACnet yet. So anybody who's listening, who's a building automation specialist, just hang tight. Send us a note. Let us know you want it. We'll certainly evaluate it. But that's an example of what we couldn't do for security in an environment. We can't make the protocols themselves any better than they already are. But what we can do is intercept or become a connection or communication partner to that device that's using an insecure protocol and change the language in its entirety, every single layer, just completely different, with the only commonalities being the values shared. And the protocol that we would use, Kepware would use to share that with other systems, might then have a better security posture. Might have username and password authentication. Might then have message signing. Might then have a layer of encryption with it. So dollars and cents, really what this looks like is, Kepware using something like Modbus. There's no encrypted standard for Modbus. The customer might come to us and say, how do I solve this problem? I need to get data to Azure. And what we would suggest by asking them a few questions is, how close to the machine that's producing Modbus can we be? Can we be in the same subnet? If their IP address is 192.168.10.2, can we be 10.3? So you pass no messages outside of that subnet. It's just a single local connection using the insecure protocol. And then from Kepware, we might have a completely separate network adapter on our host system. So you haven't what might be an air gap created by two network adapters on a single host, whether it's a physical host or virtual host. Kepware is using Modbus over the local adapter with a 10.3 address, talking to a 10.2. And then on the other side, we have a completely different network connection. Maybe it's directly on the internet. But not only is Kepware, say, an air gap in that regard, the two network adapters are not going to be connected to each other just by virtue of Windows knowing about them. You have to actually actively transfer information between them. You have to tell Windows to do that. So Kepware can do that, and it can do it securely. So it takes the information from this insecure area, processes it inside of our application, inside of the runtime process that is Kepware, and effectively that's changing every layer of that protocol, just extracting the meaningful values. Then we'll turn around on the other side of that PC, meaning a different network adapter, and that's how we'll move the data outside of that process control layer. So we see that as a common solution for some of these systems that, say, aren't integrated to a SCADA system already. Let's say that need to be connected directly to the cloud, but of course you would certainly not want to use Modbus or open ports and use Modbus across the internet, right? So that's sort of a more of a product-specific benefit of using something like Kepware to solve hey, my device was created in 1975, even before SSL was invented, but it has an Ethernet port that was tacked onto it. Can I just connect it to the internet? The answer is no. You could, but you shouldn't. But applications and products like Kepware with certain features can help create both protocol translation into a secure protocol, and then the right combination of topology and air gaps to prevent, to prevent additional attack vectors from being created. There's also considerations about protocols like MQTT, and when we're using HTTP, getting that out of the network. So some of our customers with security consultants involved might say, hey, instead of OPC UA, I want to choose a protocol that is initiated from on-premise. Do you guys have any protocols that I can initiate from inside my network to the outside so that I can keep all of my inbound ports closed and just open an outbound port? And those would be things like MQTT and HTTP. OPC UA has a standard that is similar. It's just relatively new and it hasn't been implemented yet. It's called OPC PubSub. But theoretically, that could also cause a connection initiation from inside the network, but have a bidirectional conversation from that say premise side initiated connection.
Targeted ransomware has emerged as the pervasive cyber threat to manufacturing operations. In 2020, all plant downtime due to cyber attacks was because of targeted ransomware. This is in spite of the IEC 62443 security design at these plants. A new ebook from Waterfall Security Solutions looks at targeted ransomware and manufacturing systems in detail. In the book, Dr. Jesus Molina concludes that a big part of the problem is incorrect classification. We need to distinguish business-critical IT systems from operations-critical OT systems. Once we have identified our systems correctly, Dr. Molina looks at what to add to the 62443 style defenses. It turns out we can enjoy the benefits of modern, connected automation without suffering the risks that come from connected automation. To understand 2020's lessons and explore modern solutions, please download the new ebook. You can find it at the Waterfall Security website in the White Papers area under the Resources menu.
So Nate, what I hear Sam describing here, he hasn't used the words, but I hear him describing a security gateway function. So he's saying this Kepware stuff, the OPC stuff, the protocol translation is not just about the protocol, it's also about security. And so, yes, you can have device protocols coming in. Most of those device protocols, they don't have any kind of encryption. They don't have any kind of built-in security. They're wide open. They go into this middleware function, this protocol translation function, and what comes out is, a thoroughly secured, encrypted, modern protocol. So it's not just converting these difficult, device languages into a modern, widely used language. It's providing a layer of security to the industrial devices as well.
I see. One thing that tripped me up, at least in his description, was he gave an example of an air-gapped network, a computer system where one network is connected on one side to the internet and another side to an internal network. I didn't really get what was air-gapped about the picture he was painting, so maybe you could clarify that for me.
Yeah, so we've used the word air-gap pretty consistently in this podcast, the two of us and all of our guests, to mean a network that has no online connection, sort of no network connection, directly or indirectly to the outside world. And the thing is that, in the industrial community, that term is used in a couple of different ways. One way is the way we use it, but another way that people use the term, they say a network is air-gapped if there is no way to send a single message, an internet protocol message from any device in the network straight out to the internet. So it's talking about the lack of a routable connection to the internet. And that's what he's described here. He's sort of from that community that uses the term air-gapped that way. It is possible to, move information through messages into this intermediate computer and from the intermediate computer out to the internet, but he's saying it's different messages, and that's what makes the internal network air-gapped. So we've talked a lot about where this sort of protocol conversion, this security gateway thing might fit. But our topic is encryption. Can you start taking us a little closer to the encryption and how it works?
In encryption, I just wanted to mention, it is an incredibly important tool for increasing, let's call it a security posture. Really, it's about, making it difficult to see what's being sent, but it's only one tool in a toolbox that needs to be quite a bit larger than that. So I would say the focus on encryption is useful, but it really should be broken down a little bit too. So breaking down a protocol that supports encryption, it needs to do more than that, and most protocols do. So, for example, OPC UA, Unified Architecture, it's the latest OPC standard from the OPC Foundation. It uses a security mechanism at the transport layer called transport layer security, and this is the initialism is TLS. This is a successor of Secure Socket Layer, which is SSL. But the security aspects that transport layer security bring you is unambiguous determination of endpoints. So you will always know that the person you're targeting is who they say they are, unambiguously, guaranteed. Next, you have authorization, or sorry, let's say, I saved that for last. Next, you have message signing. So for us operations tech folks, message signing is like a CRC checksum on your value. It's just a bit more complicated than that with more math involved. But it essentially is guaranteeing that the data that is sent is trustworthy. Nothing was changed in transit. It's a thumbprint on every message, right? Then you have encryption. So even before we've talked about obfuscating the actual payload, you need to have those other layers to have a good security posture. You need to have certificate swaps in order to prove that the endpoint is who they say they are. You need to then have message signing to make sure that the messages are not manipulated in flight. And these are things called man-in-the-middle attacks. Message signing helps prevent those, with or without encryption. You can at least add a thumbprint to the message to say, hey, yeah, no bytes were changed in flight. It's good. Then finally, you can do both of those things, unambiguous determination, message signing, and then you encrypt the data in flight. And that is a 3-layer security mechanism there for that single protocol. So unambiguous determination of endpoints, message signing or thumbprinting your messages. And then finally, after you've done those two things, you encrypt the messages so somebody can't see what you're passing. But you can see encryption is just one piece of the puzzle. It certainly is not the only thing that needs to be done. The next thing that good protocols do, if they have security in mind, is add a layer of authentication, even above and beyond those layers. So those previous things I talked about were features of the transport layer security protocol, TLS protocol, that are added in. Now, OPC UA does one better than that. Once you've been able to unambiguously determine that you're talking to the right person, you've signed your messages with a thumbprint so you know they're not changed in flight, and then you've encrypted the whole shoot and match, OPC UA adds another layer of security on top of that through username and user authentication. And within user authentication, not only can you pass a username and password, but there is a better authorization mechanism that can be done with another level of a certificate. It's called X509 certificate authentication with an OPC UA. So instead of passing a plain text username and password, you can pass a far more complicated proof of identity. So that's really 4 layers when in an encrypted protocol. So if you just say, hey, OPC has encryption, you're off and running, really that's only one of 4 security features that should be discussed.
You know, the workhorse here seems to be TLS, the modern workhorse of the modern internet. I mean, HTTPS uses TLS. Everyone uses TLS. The thing about, TLS that I've heard is, look, TLS relies on these certificates. The certificates have to be created by certificate authorities. You have to have access to certificate revocation lists. I've been told that it's kind of hard to do all this on an industrial network. Can you do all this on an industrial network? What's your experience working with this technology in the industrial context?
Yeah, it's a great question. It is hard. It certainly is hard. I think there are technology solutions being created now to make things easier. For example, we've had customers ask us for programmatic API access to our certificate store, so that when they create custom bespoke certificate management applications, they can do so. They can interact with Kepware programmatically, quickly, easily, as part of an automated deployment of new cert. So peeling back those onions, those layer of the onion a few, it is extremely important to manage certificates related to TLS. But certificates, this type of mathematical encryption algorithm does seem to be the most popular and best suited, mechanism to secure and obfuscate Ethernet-based communications. Now, I'm not saying it is. I'm just saying that it seems to be, based on the adoption rates and the prevalence and the mathematical theory behind it. But it certainly may not be the end-all be-all. But around managing certificates in operations tech, specifically, it needs to be done. There's no getting around it. What we've even seen vendors, big commercial vendors, whether it's us, like PTC and Kepware, change the expiration date of our certificates, so they expire much more quickly, which creates more administrative overhead for our customers. But they simply have to do it because we're enforcing that change in our product because of guidance from cybersecurity and Department of Homeland Security and other areas. So we have some of these enforced changes to certificate expiration that creates more work. So this is where some of those customer requests for us are coming from. Hey, I realize I'm a customer. I realize that I have to manage certificates as part of TLS or SSL. These are the protocols I'm using with TLS and SSL. So for Kepware, it would be OPC UA, HTTP, MQTT, maybe one or two others that I'm not thinking of, but typically these northbound protocols that are more web-centric. And if folks are using those standards, then yeah, they're going to have to do it. And so what we're trying to do is make that management for them easier by offering them an API. There are other technologies that are coming onto the scene, certificate management applications with API access to other systems. So this is getting better and easier, but yeah, it is certainly a problem, but it's a necessary evil.
So this was a tricky one. In reviewing the recording, I realized I did not understand Sam's answer here, or bits of it. So I called him up and I asked, hey, look, let's say that I'm trying to use standard TLS with standard PKI certificates. I'm trying to set up a connection deep inside an industrial network. My client machine is not going to be able to connect out to the internet, to the certificate authority, to ask if the server's certificate is still valid as it's negotiating the connection. What do I do here? I mean, do I have to set up my own certificate authority on the industrial network? And Sam answered no. Almost nobody sets up their own authority. It's just too hard. He says he sees a lot of self-signed certificates on industrial networks, which means that when those certificates time out, and you have to generate new ones and install the new ones, well, the machines, the clients that see those new certificates, they're going to complain. And there's generally human intervention that's needed to press a button and accept the new self-signed certificate. He did mention that customers were asking for a programming interface, an API, to that certificate stuff so that they could automate these certificate management tasks. And he clarified on the phone that Kepware today has a command line interface to the certificate management functions, and so people are using a lot of scripts today to automate the task of managing those certificates. I understand you're starting work on a new white paper on smart manufacturing. So I've been watching the industrial internet for some time. I was one of the co-authors of the Industrial Internet Consortium Security Framework, and whenever I go to one of those meetings or I sit on one of those calls, there's all sorts of talk about edge devices. This is a device physically connected to a sensor or a controller, like a PLC or sort of a much more specialized device. Edge devices punching encrypted, TLS or other encrypted connections straight out to the internet from the very lowest levels of the industrial process, and connecting to cloud applications. And this seems, to me as a longtime industrial guy, sort of counterintuitive. Is that really what's happening in And I'm told the discrete manufacturing space, is the leader in that space. Is that really what's happening? What do you see happening in that space?
I think there's two reasons for that. So first, I'll talk about what I see happening, and then I think I can talk about two reasons for that that I'm aware of, at least. So first off, yeah, I can validate that folks are absolutely doing that. I mean, even 6 years ago, when Kepware was rising in prominence because the problems we solved became more important to solve, right? So we started creating graphics where typically we're part of a very structured Purdue or ISA 95 network with network segmentation and DMZs all over the place. But we created a graphic that has all those layers plus a big bar going directly from internet cloud, bypassing all those layers, but mutually exclusive of those layers directly to Kepware, where we were at layer 0 and 1. So, we saw this coming, and even I hadn't been in automation that long at that time. I'd been in enterprise IT far longer. So part of me was like, hey, okay, what took you so long? The other part of me was knowing about how operations tech is typically done. I'm kind of scratching my head saying, isn't that part of an HMI system or SCADA system already? And if it's not, why wouldn't you do it through the HMI and SCADA system instead of bypassing all of that great network security you might have put together and sticking, some brave new vendor's, capital E edge, capital D device that is going to, do everything and make toast for you too, and get your coffee. Stick it down as close to the system as possible and connect up the internet. So I was really scratching my head and saying, hey, is that a good idea? Why would you want to do that? Is it a bad idea? Why hasn't it been done already? So I then went to one of our big automotive customers, and I'm talking with their SCADA and HMI management folks, and they've got thousands of instances of Kepware, typically using a few different protocol drivers to talk to programmable logic controllers. And our clients are typical OPC DA connections, custom applications, OPC UA connections from SCADA and HMI. So pretty classic operations tech. And they've got all of the network topology layered, say, to Purdue standards. And then they said, oh, yeah, those guys over there, they also have some Kepware licenses. And I said, oh, what are those guys doing? They said, oh, those guys are with the enterprise IT team. They're doing some big data analytics. I said, oh, cool. Are they using Kepware to get data from what? I mean, Kepware's already getting this data, aren't they? And they said, yeah, well, Kepware is getting a subset of the data points from the PLC, and we've developed the SCADA applications and some MES applications around, say, 40% of that PLC's data. I said, oh, okay, well, why don't they just come to you to get the data? You're already getting it for them. And they said, well, they're actually interested in using the last little 10% of that data plus the 40% that we're using. So they have different data acquisition needs even. So their data science is not necessarily needing the same variables from the PLC that the SCADA display or historian system needs. So that was a big realization for me. It's like, oh, there's different use cases, and those different use cases require different data inputs. Okay, that's one reason maybe to go alongside of the control system that's already been in place with good network stratigraphy and bypass all of that and just send it out to the cloud. But then I said, okay, well, why didn't they work with you to expose those additional data points through the already running instance of Kepware? That could have been a single point of access. Hey, wink, wink, nudge, nudge, you could have gotten to manage that too. And they said, well, for us, making a change to the SCADA system is really hard. It's a SCADA system that our whole company relies on. So it's not just as easy as, oh, hey, Kepware, AutoGen, hey, don't delete those tags. We want to grab those ones. Hey, look at that. It's now available. There's change requests. There's disruption to operation potentially due to those change requests. There's a whole layer of validation that has to happen. And for certain aspects, if you have an IT team, especially right now, and who are very interested in proving value of new methods and new, analyzing new data sources, picking up stuff, basically with a whole set of different use cases, the process of integrating those requirements into the existing environments are sometimes such a barrier to entry that it would never even make sense to get started.
Andrew, admittedly, I feel like I'm losing the forest for the trees here.
Let's back up a bit. I asked, do we really see edge devices punching TCP connections, through many layers of firewalls all the way out to the internet, to the cloud? And Sam's answer was, yeah, cloud connectivity is happening. Sometimes it's new devices connecting straight out to the internet. Other times, the sensors are there in the control system already. The PLCs already have access to all of the data that we need to push out. And what we're seeing is a bunch of new OPC servers pulling that data from the PLCs and pushing the data out to the internet in a modern protocol. The question then was, now look, if the existing PLCs already have the data, why do we need these new OPC servers at all? Why not just change the control system to push all the data we need all the way out through existing control system databases, historian, whatever, channels? And Sam said, look, if we changed all those layers of applications all the way out to the internet, the entire stack of applications, the engineering cost would be huge. Verifying that all those changes would not somehow impair all of the functions of the control system that we rely on. It's easier to just verify the impact of a few new OPC servers, asking a few extra questions of the PLCs and pushing that data away. So you folks have been leaders in all of this kind of industrial connectivity, from the lowest levels of the industrial enterprise all the way up, to the internet cloud and everything in between since, a very long time. What's the latest? What are the latest developments here? What's happening in this space?
Gosh, you brought up how we've been doing this for a long time, but you wouldn't believe it, but or maybe you would because you've been in this space for a while. But we were using Modbus as a Kepware to Kepware communication standard for a long time before we had better options. And I know of at least a few customers who were passing, Modbus directly over the internet and okay with it, right? So we've certainly evolved since then. I can't think of anybody who's come to me with that architecture in a long time. But what I'm seeing today is lots of interest in stuff that's never been connected before. So funny enough, we're seeing far more requests for bespoke or custom serial and Ethernet protocols from CNCs, molders, custom machines. Basically, they haven't implemented somebody's hardened, commercial off-the-shelf PLC. They've got a custom piece of automation, or maybe it's an older PLC or a different PLC with no commonality and Ethernet or protocol standards. So there's a lot of interest in customers taking this stuff and using Kepware or an equivalent tool to speak a custom language to this machine. We're still doing a huge clip of business with traditional driver sales and SCADA and HMI driver sales. So as much as you asked about edge technology in the previous question, as much as Kepware is one of the most important pieces of software for those edge systems that are bypassing layer 7, 6, 5, 4, 3, 2, and going all the way from internet to layer 2. As much as Kepware is a very important part of those types of integrations, Kepware traditional business of providing access to HMI and SCADA, historians, MES, ERP, that is still an incredibly large portion of our day-to-day work. So we're certainly seeing a lot more modernization efforts that might push the envelope in terms of topology, maybe push the envelope in terms of protocols employed in the automation space. We're still seeing a whole lot of people just doing that still traditional HMI and SCADA. And the nice thing is that if you do have a customer who's focused on HMI and SCADA as a centralization aspect for this automation data that's highly valuable to the rest of the organization, most of those SCADA and HMI and historians have a nice way of sharing it with others. And Kepware can help share that data. Systems like Kepware, protocol handlers can help facilitate that exchange. There's lots and lots of interest in connecting to those existing HMI and SCADA systems. So, just as many times as we get requested for Kepware on an operator panel talking to a FANUC controller in a CNC, we're asked, hey, does Kepware have a driver for Wonderware Orchestra? Because I have all my data in there and I want that to go to the cloud. So just as many times we're involved in something like that now, which that is even net new in the past 10 years. We've had the ability to do this. It's just when we've done this before, it hasn't been as much interest from big data analytics apps needing this data or clouds needing this data. Of course, now this all gets into conversations we have now about security. So how does any of this happen securely? And then, of course, it then gets into a conversation about what does the data look like? You and I know that everything we deal with is unstructured, raw data, very little relationship between these individual variables. And these modern big data systems just kind of blindly assume that you're going to have a better quality data than we do. So there's a desire to have modeling done, pre-processing of data, contextualization done before the data sent to those higher level platforms so that the higher level platform work is just a whole lot easier. So analytics and data scientists, business analysis, those use cases are really demanding new types of conversations about how do we pre-process the data before we hand it out to that OPC UA interface? Can we add metadata to the tag, or can we make a super tag out of 2 tags? How do we imply more context than what the raw data from the automation device actually gives us? Can our tools help with that? So contextualization has been a big part of our daily life too.
Well, this has been great, Sam. Before you leave, can you wrap up for us? Is there a thought you'd like to leave with our listeners?
Absolutely. Yeah. So in general, security is so much more than encryption, and encryption is just one piece. It's an important one, but it is certainly not the best way to approach a security paradigm. Let's say there's lots of tools at your disposal, and encryption is one piece. I'd say for a given problem in general, so many tools exist today, and so many different ways to design a good solution exists that making the process of picking a right solution has become more complicated than it ever has been, in part because there may be more than one right solution. But simultaneously, with great power, or let's say, great responsibility comes to great power, there's a whole lot more you can do today than you could in the past. There's way more things that are possible. And in part, this is a mixture of really amazing commercial products and really well-developed community-supported open source tools. And so the message I want to leave all the listeners is that the time has never been better for folks to get involved in industrial automation, digital transformation, security. It's becoming skill sets that are more relevant for a modern economy than ever before. So if anybody is interested in industrial automation and maybe even pursuing a career in industrial automation, I'm on LinkedIn. I'd love to have a chat. Feel free to reach out, and may the security force be with everybody, and may everybody follow good security best practices.
Andrew, as part of our last word here, we went over a lot of granular detail in this episode, but I could use more of the big picture. Is that something you could wrap up for us with?
I'd be happy to. We've been talking a lot about encryption. Where does it fit in the big picture? Encryption is a best practice whenever you cross a wide area network. It has been almost forever. What's the wide area network everyone talks about? It's the internet. If you're going to go out to the IT network, if you're going to go out to the internet, encrypt your stuff. If you're going to go out to the enterprise network, that's also best practice. Nowadays, pretty much everything on these enterprise networks is encrypted. You want to go out there, you better be encrypted. It's even working its way back into industrial networks. There are, voices in the community who say we should be encrypting absolutely everything from top to bottom in every industrial network. The problem is there's a lot of equipment that's been installed already, and it doesn't support encryption. So what we're seeing is encryption on the Purdue model level 3 and level 2 networks. But when you get down to the PLCs, a lot of the time it's still legacy stuff, and we're using these OPC UA installations, these Kepware things, to translate from the insecure legacy protocols into the more modern protocols that reach out to the modern industrial networks, the enterprise, and the internet. And, the other thing I took from this sort of a state of the practice, I was wondering, how widely this, how things are doing in the discrete manufacturing world. What I got from it is that cloud applications are coming, and the discrete manufacturing world, automobile manufacturing, aircraft manufacturing, consumer goods manufacturing, that world is leading the adoption of cloud systems in the industrial space. There's a lot of demand for more and more data in the cloud to enable business efficiencies. And what Sam is seeing at Kepware is that sometimes you buy entirely new sensors. They have their own CPU. They're these edge devices that go straight out to the internet because they natively speak internet languages. But much more commonly, you've already got the sensors. You've already got the data. You don't want to push that data through sort of the existing infrastructure because it's all change controlled. It's very sensitive. You might use the existing sensors, use the existing PLCs, throw another gateway, a security gateway there, an OPC device that talks the legacy stuff and goes straight out to the internet through layers of firewalls, encrypted, so that you can get access to the legacy data.
Okay. Then with that, thanks to Sam Elsner for speaking with you, Andrew, and thank you, Andrew, for speaking with me.
Always a pleasure, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everyone out there listening.